So we are going to begin a final exam review, and I am going to begin with chapter 9 because that's a bigger chunk of the exam than chapter 8. So chapter 9 is going to be what we focus on first. I'm just going to focus on the main ideas and like things that you should be able to do, pulling some problems from the final exam review. And then once I do chapter 9, I will jump back to chapter 8. And we'll practice some of those problems to give you the basic ideas. And then we'll go from there. And I think I'll actually split it up into 2 videos, one for chapter 9 and then one for chapter 8. That way it's 2 separate ones. So you have to watch both at the same time. So we're going to focus on, so chapter 8 is 8.5 and 8.6. And then chapter 9 is 9.1 to 9.5. And then there's P1, P2, P3. And so this is conditional and Bayes theorem. This is, what is it? Central, actually there's like a lot to it. So random variables, binomial distribution, expected value, variance, and standard deviation. What else is there? Normal, and all that stuff. There's actually quite a bit in chapter 9. And then this is mostly integration. Okay, so let's start off with 9.1, which is mostly discrete random variables. Okay. So the biggest thing that you should focus on being able to do for discrete random variables is you want to be able to do like the box problems that you see on the exam review, because those are kind of the idea that we want to focus on. Being able to construct them and use them to answer specific questions, right? And it's going to bleed into the future sections where you have to calculate like the expected value and all of that stuff, right? So that's kind of the first thing that you want to be able to do from chapter 9 is just construct a probability distribution table. So I believe, I want to double check something. Let's see, should we do number 10 or number 11? Well, let's start simple. We'll do number 10 together. So we're copying number 10, right? So one of the properties that you have to remember when doing this is that this has to add up to 1. So when you're adding them up, they have to add up to 1. X, the top row, those are the numbers that you're allowed to have. Like you can, does it make sense to have that number, right? So in the context of this problem, you're flipping 3 coins, right? And X is the number of heads. So how many heads do I flip? So my question to you is, and if you want to type in the chat, kind of like a rhetorical way, is it possible to flip -5 heads? Like, does that even make sense in the context of this? No. So -5 is not an option. Now, if I'm flipping 3 coins, is it possible for me to flip no heads? Like, can I get 0 heads in a row? Yeah. So 0 is an option. Can I flip 1 head? Absolutely. 1 out of the 3. What about 2 heads? I can. What about 3 heads? I could flip all 3 to be heads. What about 4 heads? Well, if I'm only flipping 3 coins, I can't flip 4 heads because I used up all my flips. Does that make sense where the 0, 1, 2, 3? That's what you're thinking. You know, what is the values that can satisfy my rule, right? 0 to 1, 2, 3 heads. Then you want to find the probability. And this becomes a probability question. If I have 8 coins, how many ways can I flip 0 heads? Well, there's heads, sorry, incorrect. There's tails, tails, tails. And that's the only one. So there's 1 out of 8 because I can flip the coin 8 different ways, right? And if you forgot, how did I get 8? Well, how many ways can I flip the coin? I have 2 ways, then 2 ways, and then 2 ways. So 2 times 2 times 2 is 8, right? Kind of the idea. So then I ask myself, okay, what about one heads? Well, I can do heads, tails, 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 heads, tails, 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 heads, right? So that's 3 out of 8. Good. Here I can do heads, heads, tails, heads, tails, heads, and then tails, heads, heads. So another 3 out of 8. And then this one is heads, heads, heads. So 1 out of 8. Are there any questions on how I got the probabilities? And if I add those all up, they do equal 1. So I have satisfied my probability distribution, right? And that's it. That's all the question wants is, can you construct the table? In the future, we're going to ask like, okay, what is the random variable? Sorry, what is the expected value? What is the variance? What is the standard deviation? What is the probability of getting between two numbers? And so on and so on. Are there any questions on that? I want to make sure. So this isn't a question on the review, but just because I've already written this down, let's ask a bonus question. What's the probability that x is less than 3? Okay, so we're going to start practicing like, what's the probability x is less than 3? Well, that's the probability of 0 plus the probability of 1 plus the probability of 2. Now I'm not going to pick 3 because if I pick 3, that's 3 is not less than 3. 3 is equal to 3. So then that would be 1/8 plus 3/8 plus 3/8, which is equal to 7/8. So the probability I get less than 3 is 7/8. For x, it asks the square of the number. Oh. I'll just fix it that way. But if it was the square, then you would just square it. But I'm just going to write it like that because I don't want to have to redo the entire problem. Sorry, I actually just misread it. So you would do 0, 1, 4, 9. So 0, 1, 4, 9. If you did it correctly based off of the direction. Yeah, so it would be 0, 1, 4, 9. Thank you. I didn't even, that was such a small detail. I didn't read that. But yeah, it doesn't change the probability though. It just changes that. Any questions? Sorry, I misread the direction. That's my fault. Let's say I ask the probability that x is between, sorry, miswrote that. Probability x is between 0 and 3, right? So the probability between 0 and 3. Well, also, if I do make a mistake, just like cut me off. Like, don't type it in the chat, literally just cut me off so that I can fix it, because sometimes I get focused on writing that I don't read the chat until I'm done. So if I am making a mistake in the future, just unmute yourself and cut me off. I do have volume, so we're good. So what numbers are between 0 and 3? Well, that would be the probability of 1 plus the probability of 2, because 0 is equal to 0, not bigger than 0. So then that's 3/8 plus 3/8, which is 6/8, right? Are there any questions on that? I want to make sure. All right. So that's the basic principles of discrete random variables. Are there any questions? Like, I just want to make sure before I move on to 9.2. But if you understood that, then you get the basic idea. Remember, this has to add up to 1. So if you're missing numbers, like you just set it equal to 1 and then solve for whatever you're missing. And if you're missing more than one number, they usually have to be equal to each other. Otherwise, it would be there'd be an infinite number of answers. So what I'm talking about is number 12. So they would just be two numbers that are the same that add up to 1. Okay. All right. 9.2. Binomial distribution. All right. So in class, I did give you the formula. So the formula was mentioned, although I just didn't use the formula because there's really no need to. in the sense of you're going to be doing everything on your calculator because that's just much more efficient, especially when you have to deal with what's it called? Inequalities. But just to remind you of what the formula is, gotta remind myself it because sometimes I forget. The probability that x is equal to x is equal to now I just want to make sure I do this right. N choose k, p to the x, q to the n minus x. Okay. And so where n is equal to the number of trials, I like to say the total. P is the probability of success. Q, terrible Q, is equal to 1 minus P, or the probability of failure. Probability of failure. What else am I missing? X is equal to the number of success. Basically, or as I like to say, the value of interest. So X is the number that you're actually interested in. Like, what's the probability of getting 3? Like, X is the number of interest. I call it the number of interest, right? So that's the idea, okay? So that's the formula. But we don't want to have to do that by hand. So what we do is on the calculator, the probability of x equal to x, well, that's just equal to binom PDF of n choose p choose x, right? Now, let me just pull up my calculator. I swear Windows is the worst searcher in the world. It never finds programs. Now I have to look for it. There you are. Oh, that was really, why did it do? There we go. So to get there, you do second distribution, and then you go down to binom PDF. So binom PDF is the equal sign. Okay, you really have to remember that it's the equal sign. And then if you want to do an inequality, that is binom CDF, right? So then if I want to do something like the probability that x is less than or equal to x, and that's binom CDF and PX. Now, if you have an older calculator, yours doesn't show up like this. You have to actually memorize the order that it goes in. If you have a newer calculator, you could actually change it to be greater than, but it's a little bit more complicated to do that. And most people don't have that, so I don't go over it. But you have to be very wary because your calculator by design is less than or equal to. So if they give you a less than problem, you have to modify it. Okay, so like that's super important and you have to pay attention to that little detail. Okay, so let's just practice some examples from the homework. But are there any questions so far? I want to make sure. Now, for me, I'm not going to force you to do it using the formula, but you're more than welcome to if you don't like using binom PDF. So let's just do this one together. I guess I should include the problem number. Just to, there we go. Number 13. We'll keep it simple. So let x be a binomial random variable with n equals 7 and p equals 1. Compute the given probability. P of x equals 5. Okay. So the probability, that's not the correct marker, that x is equal to 5. So I'm going to write it using the formula. And that's going to be 7 choose 5 times the probability of success. So 0.10 raised to the x, so that would be 5, times q, which is 1 minus 0.1, times n minus x, so 7 minus 5, which is equal to 7 choose 5, 0.1 to the 5th power, 0.9 to the 2nd power. And there you go, right? And so this is going to be equal to binom PDF of 7, 0.1, comma 5. And if you plug that into your calculator, I don't know why my calculator's doing this lately, but that's okay. So we have 7 trials, because that's n. Our probability of success is 0.1, and our x value is 5. I'm going to paste that. So that's how yours is going to look if you have an older calculator. It just looks like that. Press enter, and that's going to be 0.0001701, right? 1, 2, 3, 4 decimal places. Yep. So remember, scientific notation says you move the decimal to the left 4 times. All right. Are there any questions on that? I want to make sure. So just be comfortable with both, I guess. Okay. So let's just do another one. Let's do the airbag problem. Let's do that. Got plenty of time to work out a bunch of these. All right. So you're a manufacturing plant producing airbags, and it's known that 30% of them are defective. Wow, that is like extremely terrible. That's like Hyundai or Kia right there. 6 airbags are tested. Find the probability that exactly one of them is defective. If we have the answer in scientific notation, will we bark wrong? No, you should be fine, honestly. So find the probability that exactly one of them is defective, okay? So exactly one, what symbol is that? I want you to think, when you see the word exactly one, what symbol are you thinking? Type it in the chat real quick. What symbol are you thinking? I'm thinking equal sign, right? Because it has to be exactly one. It has to be equal to 1. So really what I'm asking for, what's the probability that x equals 1? Okay, that's what you got to think about. So then I have to figure out what n and p and x are. Now, you might be thinking, wait a minute, how do I know this is binomial, right? Well, think about it. Well, I think about it, what else could it be, right? You're given a quantity, 6 airbags. You're given a probability that's the same for everything. They just say 30%. They don't give you like, it's 30% for this one, 5% for this one, 7%. So when you're given a problem where they just give you like a percentage to represent all scenarios, it's a binomial distribution, right? You're going to know it's not binomial if they give you more than one probability that's different, because the biggest rule about binomial is the probabilities have to be the same for everything. So that's kind of one, little way of knowing. So probability of x equal to 1. So then we're going to say, okay, and I'm just practicing the formula. You don't, like I said, maybe you have to do it, probably not, but it's fine. So we have, what was it? And I keep forgetting, and choose x. So there's 6 airbags, right? Does everyone see the 6 airbags? And then one of them is tested, and the probability that it's going to fail is 30%. Okay. And then the probability of it failing, which is succeeding, is 70%. And so this was kind of funny. When we talk about success is like in the context of like, what is what I'm describing, right? Defective is considered success, okay? Even though in practicality, being defective is a failure, but that's where you have to be careful with these, is like success doesn't have any kind of, connotation to it. It just means yes or no. Like defective is a yes, not defective is a no, which again can be confusing. And then we're gonna raise it to the x power, which is 1. And then this is 6 minus 1. So then that's 6 choose 1, 0.30. And I know some of you have already done these, so if I'm doing it wrong or I'm getting the wrong answer, just like cut me off and say, hey, I think you're doing it wrong. And we'll adjust, right? Had a long week and I am not at my peak right now. So let's see, 6 total, probability of defective is 30%, and I just want one of them. And let's see what that equals. So let's do second distribution, all the way down. Binom PDF, not CDF. The number of trials is 6 this time. The p-value is 0.3, not p-value, but p is. The x value is 1. We paste it. We enter. And I get 0.3025. Let me check the answer key because the answer key will tell me if I'm right. Thankfully, they haven't. Sometimes these reviews don't have. I am correct. Good. So we did it right. Any questions on that? I want to make sure. So now we want to say, okay, what is the probability of getting x bigger than, well, it says at least 2, okay? So the question is, does that include 2? Well, at least 2 means I include 2. Okay, so greater than or 2, greater than or equal to 2. Okay, you have to give me at least 2, so 2 is okay, but I want at least, no less than 2. So now the thing is, your calculator by design and the way the formula is designed, it's a less than or equal to. Okay, so you have to convert this. Like the calculator will not be able to calculate this unless, of course, you have a newer one. So this is where you have to remember the little trick. So we're going to use the complement rule, which says I can flip that inequality to the other way, but now I have to write it in a way that it'll work with my calculator. So what is less than or equal to 2? Sorry, what is the equivalent to greater than or equal to 2, but the opposite direction? Well, do I want to include 2? No. So then I would be less than or equal to 1. Okay. And maybe that's not speaking to you. So really what I'm saying is 1 minus the probability of x equal to 0 plus the probability x is equal to 1, right? Means the exact same thing. Now let me ask you a question. Can you have negative defective airbags? Like, does that make sense? Can x be a negative number? No, doesn't make sense in this context, right? So I can have 0 defective airbags, but I can't have negative defective airbags, right? Now, do you want to do 2 binom PDFs and add them together? I mean, you could. It's not that bad, honestly, but I wouldn't. So I would do 1 minus binom CDF, and then you're going to do 6 airbags, defectiveness, and 1, because this is now 1. So we're going to do 1 minus second distribution, binom CDF, my number of trials is 6, my defective rate is 30%, and my x value is 1, and we get 0.579825. 0.579825. And then let's verify that is correct on the homework. Yeah, they just rounded to 4 decimal places. So we're good. Are there any questions on binomial distributions? I think that pretty much covers everything that we really could ask. I mean, kind of the idea. Any questions? I want to make sure because we're going to move on to 9.3, which.
Okay, I have a question.
Yeah.
For example, if the number was p has to be greater than or equal to 3, for example, would the numbers at the parentheses be a 2 then? So would it be 1 minus p x is less than or equal to 2?
So you said greater than or equal to 3?
Yeah, if the number
Yeah,
was.
yeah, exactly. Yeah, then yes.
Okay, so
so what you, yeah, no, you were right. So what you said in the chat, 1 minus P of X less than 2, 100% correct, but your calculator doesn't see it that way. That's the thing, is your calculator by default is less than or equal to. Like, that's the point. So let me go back up here and write this. Do you see the less than or equal to right here? Like, that's how your calculator interprets it. So it has to be converted to a less than or equal to. Does that make sense? It's a calculator thing, not a math thing. It'd be cool if your calculator let you change the inequality like explicitly, but it doesn't, unfortunately. So the probability that X is greater than, I don't know, a number, let's not do it that way. Let's just actually use a number. 5 is the same thing as 1 minus the probability that X is less than or equal to 5. Because think about it. Do I want to include 5 in the opposite direction? Yes, because 5 is not bigger than 5. It's equal to 5. Whereas if you have the probability that X is greater than or equal to, I don't know, 7, you would do 1 minus the probability that X is less than or equal to 6. You have to go down 1 because you don't want to include 7 in the complement. And then just in case, if you have the probability that X is less than 3, well, that's the probability that X is less than or equal to 2. Okay. Again, the whole point of doing this, right? The whole point of doing this is for your calculator. That's the whole point. Your calculator only reads it that way. Unless, of course, you have a fancy one that lets you modify it, which I don't, and I don't think most people do either. Any questions on that? Okay, so we're going to move on to 9.3, okay, which is measure of central tendency. Now, I wish we had an and I wish to ask you a question on the exam, like, what's the average? Like, what's the average of these like 5 numbers? Because, I would hope everyone got that one right? But I mean, I'm still going to tell you what the formula is because, maybe you have to compute it, right? So you never know. Maybe they will be nice enough to give you I call it like a softball question, but who knows? Maybe they give you a hard version of it. But so the mean is X bar equals to, whatever number of data points you have divided by the total. Okay, so X1 plus X2 plus X3 plus ... Xn divided by n. Okay. And then the median is just the middle number of ordered list. Okay. So mean and median. And then the mode was most repeated. So the only one that really had a formula was the mean, okay? And the mean is also called the expected value. So they end up being the same thing, okay? So you know what, let's just do one of the homework questions. Let's do one of the review questions where you actually have to use like this mean formula. And then we're gonna move into like the expected value with probability. So actually I'm gonna do this real quick. So yeah, let's do one of the review questions. Number 18. So after bowling 5 games in a bowling league, James has exactly a 150 average. What does he have to bowl in a 6th game to boost his overall average to 152? So if you've never bowled, a perfect score is 300. Anything over 100 is considered okay because, most people don't usually get that unless they're really trying. And then if you're like a good bowler, you're in the 200s, right? So if you get over 100 when you're bowling casually, like that's kind of nice, but just depends. Okay, so they say you bowl 150 average, meaning your first 5 games, you're adding up to, what's it called? 150 average. So my question is like, what do I have to bowl in the 6th game to get a little higher of a score? Well, so let's just think about it. My first game, I don't know. My second game, I don't know. So we know that when we bowled the first 5 games and we divided it by 5, this is equal to 150. Like, does everyone see that? Want to make sure. So our first 5 games resulted in a score of 150. And so the question is, okay, now we want to know if I bowl one more game, and I'm sure there's many ways of doing this. This is just kind of one interpretation that I've seen. We want it to be equal to 152. Does everyone see that? So I want to get all of the games to add up to some number, then divide it by 6 and get 152. Okay. Well, like I said, there's like so many ways you can do this, but again, my goal, sorry, keep going in circles, is to find what this is. Okay, I want to find that game. Well, if you think about it like logically, you know you have to score higher than 152, otherwise your number would be below 152. And I mean, you can kind of guess and check, but since you don't know what the other games are, you have to kind of use a little bit of reasoning to get it. Okay, so this is kind of how I've done it, where, okay, I'm going to multiply the 6 over. I'm going to multiply the 6 over. And I end up getting x1 plus x2 plus x3 plus x4 plus x5 plus x6 is equal to, I don't even know what that number is, 152 times 6, which is 912. Okay. Then I think about this. I'm like, hey, I noticed something. Again, maybe you never thought to do this, but now that you've seen it, you can kind of think about this. I noticed this right here. Like, this is x plus 1 plus x plus 2 plus x plus 3 plus x plus 4 plus x plus 5. So what if I multiplied the 5 over like that? And then this right here becomes x1 plus x2 plus x3 plus x4 plus x5 equals, let me do 150 times 5. Not that big of a number. 750. Right? And so do you see how this whole thing equals 750? So then what does this whole thing right here equal to? 750, right? So then I can say 750 plus x6 equals 912. Well, now I just subtract both sides by 750. And then this tells me that x6 equals 162. Like that. Okay. Kind of a weird problem, I know. It's just kind of being clever. But maybe now you kind of see the trick to it. And it's just going to be that trick, is like you want to manipulate it so that you can basically isolate the x plus x1 plus x2 plus x3 or however many you have, and then substitute it in the new one that you're trying to find. Does that make sense? Like I said, kind of a weird problem, but it's kind of a fun one too. All right, let me see. So that covers that kind of problem. So now what we want to look at is, okay, what if I want to find the expected value using like a probability distribution, right? So that's always a fun problem. So I want to do the roulette one because this is like my favorite problem. So let's do roulette. But any questions on number 18 that I just did? We're going to do the roulette problem now. So when you're doing the roulette problem, they're saying find the expected, or how much you expect to win. Okay. Well, you know what? I'm actually getting ahead of myself. So sorry. Let me create another slide in between because I should just tell you what the expected value is. Expected value of random variable, specifically discrete, but it's all the same. Okay, so discrete. So the mean or the expected value which is mu, we call it mu, like that's the symbol of it, is equal to the sum of each random variable times its probability x, okay? So that is the definition of the expected value for a random variable. I mean, it's also called the mean, okay? So that's the formula you have to remember for expected value. And then we're gonna move on into, you know, what happens when we have like a binomial one. Oh yeah, I should probably do that. So this is just for any. And then for a binomial distribution, oops, wrong letter. The expected value is NP. So this is for the binomial. And that only works for binomial, so don't do it for anything else. Okay, so if you have a binomial problem, you can calculate it pretty much instantly. So now let's go back to our problem, okay? So we have a roulette table and it's 1 through 36, 0 and double zero. And so you're gonna bet on 4 numbers. So you're not betting on 1 number at a time, you're betting on 4 numbers at a time. So when you win, if you bet $1, you get your $1 back plus another 8. So whenever you're doing these problems, you want to do the net winnings, not the gross winnings. So you don't count that dollar that you bet because you didn't win it, you just got it back. But it doesn't count as part of the winning. So just be a little aware of that, what's it called? Detail. Are we going to be asked questions for the non-binomial U equation on the exam? You mean mu? Like this one right here? Is that what you're talking about? Yes, like that. This is the one we're doing right now. Like we're doing this one right now. You definitely need to know how to do this because this is an important one. The binomial one's just like a shortcut. So we're going to create a table for our random variable. So x, okay, they don't tell you what x is. You kind of have to figure out what x is. So x is going to be the number of dollars won. That's how many dollars you win. Because remember, a random variable has to be a number. It can't be anything else besides a number. So we have to define winning in terms of a number. And then I want to know what's the probability of x, like of getting that number. So if I win, how much do I win? Well, they tell me if you win, you get another $8. So plus another 8. So when I win, I get $8. When I lose $1. So minus 1. Does that make sense? Are there any questions on that? You can do it in any order you want. Now, what is the probability of me winning? Well, there are 38 options, right? 38 options. And I am picking 4 of them. Okay, so 4 numbers. So the probability of winning is 4 out of 38. So then what is the probability of me losing? Well, the other 34 out of 38. That's the probability of me losing. Okay. So mu is equal to the expected value, using the wrong symbol right there, which is equal to the sum of each random variable times its corresponding probability, which is going to be 8 times, I guess I'll be super detailed, times the probability that x is equal to 8 plus -1 times the probability x is equal to -1, which is 8 times 4 over 38 plus -1 times 34 over 38. And if you do that correctly, and I'm going to calculate it to myself just to verify that I am doing it correctly, plus, I guess, minus 1, 34 over 38. Do I need to do order of operations here? Yes, I do actually. That doesn't make sense. Does it? Oh, let me check the answer now. Because maybe I'm just using the calculator wrong. Number 21, -5 cents. I mean, that makes sense. A negative 0. Wait, hold on. Oh, I see what I did wrong. That's my fault. I was doing 8 times 32 because I was like doing the mental math in my head. Okay. So negative 0.0526. Okay, now we're good. So basically what this says is that every time you spin the wheel, whether you win or lose, in the long run, you're losing 5 cents. So like if you played the wheel 100 times, you would lose $50 in that long run. You'll win some, you'll lose some, but in the long run, every time you spin, you're losing 5 cents. So that's kind of the idea. Make sure you put units on it. Okay. Any questions on that one? Like I said, I really like that one. It's a roulette. Pretty interesting. And I think that covers measures of center. I'm trying to see if there's anything else that you have to do. Nope. Yeah, that covers it. Yeah. Any questions? So now we can move to standard deviation and measures of dispersion. So 9.4. Which is just standard deviation and variance. Okay. So where did you go? 9.4. So I showed you how to do the, can we do a binomial one? Sure. Actually, go to a binomial problem earlier. Here, I'll do it off to the side because that's how simple it is. Find E of X. N equals 6, P equals 0.3, mu equals 6 times 0.3, which is 1.8. That's it. Just got to find N and P, which you already know. Does that make sense? Like that's the beauty of binomials. Like it's that simple of a formula. Whereas the other one, not so much. Okay. Did that help you? I just want to make sure. All right. So the variance just kind of gives you the idea of how spread out the data is, but it doesn't actually like tell you anything because its measurement is not compatible units with the mean, so spread of data. It's just like the general spread. That's what I like to say. And so the formula for the variance and this notation we use is sigma squared is equal to the sum of each value x minus mu squared divided by n. Okay. I would memorize it this way. Like I did give you an alternative formula in class. This one is a little bit easier to remember because there's a lot less headaches going on. Now, this is for a population. So if you want a population variance, and then if you want a sample variance, I guess I should say that, population. And then a sample variance. I mean, it's really the exact same thing. HQ S squared. Still x minus mu squared. But it's divided by n minus 1. Okay. So if I say sample, you just divide it by n minus 1. If I do population, you divide it by, what's it called? N. Now, if you're wondering, how do I know if it's a population or sample? Well, truthfully speaking, it's always better to assume it's a sample. So I would always assume a sample unless told otherwise, right? And the reason for that is because most of the time in statistics, you actually don't know what the population is. So I would memorize this one. Okay, please. That's the one I would memorize. Okay, because like I said, we usually don't know the population. We know this is the sample. Okay, now I did show you how to do this in the calculator, and I'll show you again in a moment with an example. But now if you want the standard deviation, And so the standard deviation is the spread of data relative to the mean. So the variance does have no relationship to the mean, whereas the standard deviation is built off of the mean. Okay. And so the population, and I abbreviate standard deviation as SD, is equal to sigma, which is equal to the square root of the variance. Okay. And then the sample standard deviation is equal to S, which is equal to the square root of the variance, once again, which is the square root of S squared. Like, don't memorize the formula, okay? Are we going to need to solve for sample variance without a calculator? You might have to for a distribution, but I'm going to show you how to do it with data on the calculator, okay? It's not that bad, and you do have an hour and 50 minutes. And like I said, and I've said this before, I wouldn't give you more than like 5 data points to do it by hand, because then it would just take too long. So at least be able to do like 5 data points and you'll be fine, okay? So let's do an example. Hopefully they have one on the review. Yeah, there we go. Oh, it's been an hour already. We're just a little long. We might have to go past 10. That's fine. This is the only final I have tomorrow. All right, find, so the following sample, look, notice that they write sample. It's gonna be a little longer than the original exam. I don't know how many questions exactly it is. Our normal exams were like, what was it, like 10 questions and like 3-4 free response. I just think it's gonna be more multiple choice / short answer, and then like maybe one more free response, because we have to grade these, right? So, and we have to grade them quickly. So I wouldn't say more than like 20 questions tops, because you like our last 3 exams were like 16, I want to say, something like that, 13 to 15. So double the time, almost double the questions, I guess, but it won't be too bad. All right. So compute the sample mean, X bar, and the standard deviation, S, using the formula method. Okay, so we'll just practice the formula method. So X bar, and just add them up. 4.2 plus 4.7 plus 5.4 plus 5.8 plus 4.9. Honestly, I won't really require you to use the formula method. If you want to use your calculator, just use your calculator. And then to that question of, is there an alternative version to the x minus mu squared times the p of x? I think there is. It's just, I don't think it's any better. Like, it's better for him, it is better by hand, like to do it by hand, but it's not better to memorize, because it's a little bit more complicated to memorize. Okay. And then we count how many data points. 1, 2, 3, 4, 5. So we divide by 5. And I will quickly calculate this. 4.2 plus 4.7 plus 5.4 plus 5.8 plus 4.9. And then we divide by 5. And my 4s look terrible. I got 5. That's a nice number. Okay, 5. And then you're not going to calculate the standard deviation first. You're going to calculate the variance and then square root it at the end. So we're going to calculate sigma squared, which is equal to the sum, right, of x minus mu squared divided by n minus 1 because of sample. Got to remember that. And so this is equal to 4.2 minus 5, because this right here is 5 from right over here, squared, plus 4.7 minus 5 squared plus 5.4 minus 5 squared plus 5.8 minus 5 squared. I ran out of room. plus 4.9 minus 5 squared. I think I can fit it in there. Sorry, I just don't want to make it a new line. And you're gonna divide all of that by 5 minus 1. And if you do that correctly, I'm not actually gonna spend time doing that by hand. I'm gonna assume it's correct, and if I'm wrong, please let me know. 22, so sigma squared is equal to 0.36. Any questions on that? And then, sorry, I've been using the wrong symbol. Let me fix that. S. So then S is equal to the square root of 0.36, which is equal to 0.6. And so that's the answer. Okay. Any questions on that? Now, if you want to do this on your calculator, turn it on. So click on stat, clear that, click on stat, and then you're going to press enter on edit, and you're going to type in your numbers. So 4.2, 4.7, 5.4, 5.8, 4.9. Okay. And then you're going to do second quit, and you're going to do stat, and you're going to do calc, and you're going to do one var stat, and you're going to press calculate. And then X bar is 5, and then SX is the correct answer. So it was 0.62. 0.6 and 5. Any questions on that? Now, that is standard deviation. That is, I mean, this is the variance right there. And we've calculated all three. So now what I want to do is I want to talk about doing this for, what's it called? Sorry, random variable. So let's do this for a random variable. And we'll do number 25 because, again, that's just kind of a fun one and I did get questions on it, so why not? And then for those of you who watched the video, I'm going to teach you, because another student actually taught me, what do we do on the calc after the list? Yeah, no worries, I'll go back. So after you make your list, you click on, what's it called? Stat. And then hit the right arrow key and go to calc. And it's the very first option, one var stat. That just means one variable statistic. So press enter. And then as long as your L1 list is selected, go down to calculate, press enter, and then you're good to go. Okay. So one of the students actually told me about being able to do the, what's it called? Random variables in calculating E of X, V of X, and sigma of X on the calculator. So, you know, we'll test it out and see if it works. And if it does, you guys can use it. And for those who watch the videos, we'll have a little extra advantage. Okay, so calculate the expected value, E of X, the variance, V of X, and the standard deviation, sigma of X, of the given random variable. Once again, getting ahead of myself, should probably give you the formulas. Random variables and E of X. I know I've like kind of jumped around with the notation. I've seen var of X, V of X. It's all the same. No, it's really all the same. So, you know, given a random variable X and a probability P of X, the expected value is not a shocker because we know this. The sum of x times p of x, like that's from 9.3, like that's the section before, like that's not new. The variance, on the other hand, that is new. So this is equal to, this is where it gets a little confusing the first time. It's the expected value, but instead of at x, it's x minus mu squared. So it looks kind of weird like that. So what you're doing is you're going to replace this whole thing right here. You're going to replace this and you're going to put it into here so that you get the sum of x minus mu squared times p of x. Like that's how you get that formula. And then the standard deviation is just the square root of the variance. So just take the square root of whatever number you get. Okay. Are there any questions on that? So those are the formulas. So now we can do this example. But actually, let me just give you a quick second. And I'm actually going to pause. Okay. So let us go to this problem. So we're calculating expected value, variance, and standard deviation of a given random variable. So they say that x is the number of red marbles that you're holding in your hand, assuming that you pick 5 marbles. So you have 5 in your hand, and there are 5 red and 2 green. So my question to you is, if you think about it, if you have 5 marbles in your hand, what is the least amount of red marbles that you can hold? Like, is it possible for you to hold 1 marble in your hand that's red? No, because there's only 2 green, right? So what is the smallest number of red marbles you can hold in your hand? Like, think about it and type it in the chat if you want to. But what number is the smallest amount of reds you can hold? 3. Because if I hold 2 red marbles and I put the 2 greens, I only have 4 and I need all 5. So I have to get another red one. Now, can I have 4 red marbles? Absolutely. Can I have 5 red marbles? Absolutely. Can I have 6 red marbles? No, we don't have enough marbles to do that. And the question says you can only hold 5, right? So does everyone see where the 3, 4, 5 came from? It's the number of red marbles that I'm allowed to hold in my hand. Okay. Maybe that part was confusing first. Okay. So now I have to calculate the probability for each one. So what is the total number of marbles that I can choose from? Well, sorry. There's 7 of them. And how many am I choosing? 5. Okay. And then, so each of these is 7 choose 5. 7 choose 5. 7 choose 5. And so in the first case, how many red ones do I have? I have 5. How many am I picking? 3. How many green ones do I have? 2. How many am I choosing? All 2 of them. Does that make sense? Any questions on that? And so from there, I just keep going with the idea. I have 5 red, picking 4 this time. I have 2 green, only choosing 1. 5 red, choosing 5. 2 green, choosing 0 of them, right? Are there any questions on that? Now, does the solution have the actual numbers for that? I don't think it does. Does anyone know the numbers? Does anyone have the 3 numbers for it? Because otherwise I have to manually calculate you. I don't want to do that. Guess not. So let's do them. So it's 10 over 21 for 3 over 4. Thank you. And then 5 is 1 over 21. Cool. I think that kind of makes sense. All right. Any questions though? All right. So now I have the probabilities and I have the random variables. So the expected value, which is going to be equal to mu, is just 3 times 10 over 21 plus 4 times 10 over 21 plus 5 times 1 over 21, like that. And that is going to be equal to, what were we doing, 25? 3.57. Okay, like that. Are there any questions on that? And I'm actually going to verify this just to make sure. 4 times 10 divided by 21 plus 5 divided by 21. Symbol right there. Yeah, 3.57. Yep. Okay. So we got the first answer, E of x, which is mu. Now for the variance, this is equal to the sum of each x value minus mu squared. And then we're going to multiply that by the probability of x. You don't have to divide it by n, thankfully. Or do we? I mean, sorry, it's been a while, so let me make sure. I don't think you do. Nah, yeah, it's like psyching myself out for a second, but no. So you're going to take 3 minus 3.57, because this right here is this number. And then you're going to square that, and you're going to multiply that by 10 over 21, plus 4 minus 3.57 squared times 10 over 21, plus, I ran out of room, 5 minus 3.57 squared times 1 over 21. Okay. And if you do that correctly, you are going to get, what does the answer say? 0.34. I hope. The square root of that should be the next answer, but let's just make sure. Yep. Okay. So that's the variance. And then the standard deviation is just the square root of 0.34, which is equal to, let me write it over here, because let me do this. Let me make this a little smaller. I'm just gonna move this up a little bit. I should have done that way then. And then there we go, not fit. 0.58. Any questions? So we have our answers. Not too bad. So let's test out that theory that one of the students showed me. So what you do is you're going to have to use two lists to do this. So stat, and you're going to press edit. So in the first list, you're going to type in your random variable. So 3, 4, 5, and then let's delete everything else. And then on the second list, you're going to type in the corresponding probability. So 10 divided by 21, 10 divided by 21, and then 1 divided by 21. Okay. So we've made two lists this time. And so once you've made the two lists, you're going to do second mode, and then you're going to click on stat. And then you're going to go to calc, and you're going to go to 1var stat. So it's the same thing as the last time. But do you see where it says frequency list? Let's just put something there and let's see if it works, because I think this is how they told me to do it. But maybe I confused something else. Then you do second stat. That's the tricky part. Second stat. And then we want to pick list number 2. So we're going to do L2. Press enter. And then we press calculate. And let's see if it gives us the correct numbers. So 3.57. Yep. Standard deviation 0.58. Yep. And then if I square that, I should get 0.34. So yeah, you can do it on your calculator. That's how you do it. Any questions on that? So for those who decide to watch the video, okay, you have a little bit advantage. And I think that covers everything for 9.4. Let me double check. No, it does not, because we still have to talk about empirical rule and Chevy-Chev. Okay. Let's talk about that. How do you fix a deleted list? Great question. It's very simple, actually. Click on stat, and then you see option number 5, set up editor, press enter, and then press enter, and then it should be back. See if that works for you. Usually does. All right. Let me know if it worked. So empirical rule versus Chevy. Is it Chevy or Chevy? I always mispronounce it. Chevy-Chev, yeah. Okay. Perfect. Good. So when you're talking about empirical versus Chevy-Chev, really what you're just thinking about is where the data lies in terms of how many standard deviations, right? So really, we only like the one that most people care about is like 95%, because that's kind of like the golden standard. I mean, if you're doing something a little bit more life critical, you'd probably want to do like 99% or like 99.9%. But if you're just doing your normal thing, 95% is definitely the one you have to remember. So for the empirical rule, if you're talking about 95% of data, that's between two values. Started off well, the paper. There we go. So the center is always the mean, no matter what. And so what we're interested in is these two values, right? And so if you want 95% of the data to be in here, so 95%, okay, then this is going to be x, sorry, not x, wrong letter, mu minus 2 sigma and mu plus 2 sigma, or if you write it as a interval, mu minus 2 sigma, comma, mu plus 2 sigma. If you want to do 68%, you do 1 sigma on each side. And if you want 99.7, you do 2 sigmas on each side, okay? Does that make sense? Just want to make sure. And so Chevy-Chev says that instead of it being 95% of the data between the two standard deviations, it's actually 75% of the data. So 75% of the data. And the thing about Chevy-Chevs is it doesn't have to be this nice normal curve. It can just be some like, whatever like this. But it has to be symmetric. Like that's still a condition. And so the center is still the mean. But now if I want in between, if I want at least 75% of the data, okay, it's going to be mu minus 2 sigma, and then mu plus 2 sigma. Also, just so we're clear, mu and x bar are kind of interchangeable. If it's like a, what's it called? And then if you're talking about samples, you use the bottom one. So like this right here, that's for a sample. And then the top one's for a population. Same thing here. You can do x bar minus 2s, x bar plus 2s, and then x bar. It's all the same. Like it really is all the same. Actually, can I move this? Nope, doesn't let me. I'm gonna write it down here. Okay. So sampler population. So like when that question asks you like which one's better, it's whatever the percentage is closer to, right? So if you want to find like how much of your data is actually in there, then you just count how many are in between the two data points. So let's just practice that, right? We'll do number 23, the one right after it. And then I believe we can, what's it called? Go on to 9.5. So in what range does the empirical rule predict that approximately 95% of unemployment rates will fall? So 95%, mu minus 2 sigma, comma, mu plus 2 sigma. So mu was equal to 3.57, right? No, it's at 22, not 25. So what number was that? That was 5. 5, and then the standard deviation was 0.6. So the range is going to be 5 minus 2 times 0.6, comma, 5 plus 0, wrong number, 2 times 0.6, and so it's going to be 3.8, comma, 6.2. Okay, and so that's A. Now, B says, what is the actual percentage of employment rates that fall in the predicted range? So how many of them actually fall in the range? Well, 3.8 to 6.2. Well, if I look at my data, all of them do. So B is 100%. So which one is better, Chebyshev or what's it called? Empirical. Well, just kind of plotting it, Chebyshev is 75%, empirical is 95%, and I'm at 100%. So what number is 100% closer to, empirical or Chevy? It's closer to this one, so it's going to be empirical. Empirical is the better one. Now, if instead of it being 100%, it was like 70%, then Chebyshev would be better because it's closer to 75%. And that's the whole idea. Okay. Any questions on that?
So
Alright.
like solving them is pretty much the same thing. It's just when it comes to what it's just going to ask you which one gives you a more accurate prediction.
Exactly. So if I said, what is the range for a 75% Chebyshev, it would be the same exact range. But it would only give you 75% of the data. Whereas the empirical says I'll give you 95%. Depends on the distribution. So if I said I want a Chebyshev that's 83%, is that what it was? If I said 89%, that would be minus 3 sigma and plus 3 sigma. If I said I wanted a 99.7, that would be minus 3 and plus 3. If I wanted 68%, that would be minus 1 standard deviation plus 1 standard deviation, right? Now, 95% is the most common one. So out of all of them, that's like the one I'd recommend memorizing, because in statistics, you're going to use it a lot if you take that class.
Wait, how do you know that it's -2 or +2?
Because of the empirical rule, like by definition, it's that. So let me see if I can find
So
it.
it's always 2 or no?
If it's 95%.
Okay.
Here, I'll just copy in.
Can you draw like the 68% and the 99%?
Here, I'll just throw some pictures in for you. I'm gonna find one that makes sense. There we go. Here we go. No. There, that's a copy image. All right. Any other questions? Just want to make sure before I move on to 9.5, which is normal distribution. Let's see if there's one for Chevy Chev, but I don't think for Chevy. I mean, I guess. Let's see. There we go. All right. I'll post, and I'm going to post these slides too, actually. So, but give me 1 second. I'm going to pause my screen because I need to save this. Worst thing that could happen is power outages. Lose all this good work. Not to 11. Final review. Okay, we're good. So 9.5 normal distribution. So first thing, gotta know what a normal distribution looks like. Like that. Not as, obviously a lot nicer than that. The center is always the mean. Okay. And the word standard, like if you see the word standard, that automatically implies something. Namely, that this is 0, and then that the standard deviation is 1. Like that's an automatic rule that happens when you assume a standard normal curve. Not only that, the area must be equal to 1. So we call this a density curve. So this is a density curve. Okay. Any questions on that? So what we're going to investigate and what we care about is when we're talking about a standard normal curve, we use what are known as z-scores. Okay. And so instead of using the mean and the standard deviation, we actually call this like the z-score. So z equals 0, and then we move from there. And so the z-score is the number of standard deviations above or below mean. So if you are at the mean, then your standard deviation, sorry, your z-score is 0 because you are 0 standard deviations away from the mean, right? That's kind of the idea. So when we want to calculate the area between 2 points, we can either use z-score calculations, or we can just use the normal calculator built, the normal cumulative distribution function built into our calculator. So I'm going to do it I'm going to show you 2 problems. Okay. So we're going to do number 32 first. And if you ever want to calculate a z-score by hand, it's not a very difficult formula to do. It's just your x value minus your mean divided by your standard deviation. Okay. And so where x is a specific data value. Right. So like that could be like x is right here.
Is there going to be a z-score table on the exam?
Yeah.
Given to us?
There is. You don't really need it. Like you really don't. But if you feel comfortable using it, absolutely, it'll be provided to you. It's the same one that they provided to you on the what's it called? Website.
Okay.
So let's do an example. Let Z be the standard normal distribution. Find the indicated probability. So you're just going to use normal CDF of your first value, comma, your second value, comma, your mean, comma, your standard deviation. Now, Z implies standard normal, which implies mu equals 0, sigma equals 1. So you're going to go to second. That's how you do it. Click on second distribution, and it's the second option. Do not use the first option. Never going to use a normal PDF. Press enter. So my first bound is negative 0.82. My second bound is 1.2. 1.2. My mean is 0. My standard deviation is 1. I'm going to paste it. Press enter. If you have an older calculator, you probably just went straight to this. So you kind of have to memorize the order. Press enter. And that's the answer. So 0.6778. Sorry, 6788. Now, what does this actually mean? Well, I always tell students what you should do first. And you know what? Let me rewrite this because I kind of skipped a step. Step 1, draw the distribution. So if you were to draw it, the center would be 0. And then I want it from negative 0.82 to 1.2. So I want this area in between. And then step 2 is compute. Okay. Drawing that distribution does help. Now, yes.
So anytime we see Z or standard normal, mu is automatically 0 and standard deviation is automatically 1.
Yes, absolutely. That's what that word means, standard normal. Okay. So just remember that. Standard normal, mu equals 0, standard deviation is 1. Now, if you get them backwards, the nice thing is that causes an error. So you'll get an error if you do it backwards. And I'll be like, oh, I messed up. I put it the wrong order. So that's kind of a nice thing. Okay. So step 1, draw distribution. And the center is the mean. So they tell us the mean is 31. And the standard deviation is 20. And I want it between 30 and 43. So basically, I'm trying to find this area right here. Okay, does everyone see the goal? So, step 2, compute. Now, if you're going to use a z-table, so if you're a z-table person, you have to calculate these as a z-score. Now, if you're a calculator person, all you have to do is normal CDF A comma B comma mu comma sigma. So it's going to be equal to normal CDF 30 minus 3 comma 31 comma, sorry, wrong number, 43 comma 31 comma 20. Okay, and if we plug that into our calculator, second distribution, normal CDF 30, 43, 31, 20. We get an area of 0.24568 or 57. Okay. Now, if you're a z-score person, or z is equal to 30 minus 31 over 20, and z is equal to 43 minus 31 over 20. So this is going to be negative 0.5, but that's not right, 0.5. And then z is equal to 0. That'd be 12, so 60. Okay. And then if you did normal CDF of negative 0.05 comma 0.60. Now, because you went to a z-score, what is your mean? 0. What is your standard deviation? 1. And if you calculate that, we should get the same number. So let's find out. Second distribution, normal CDF, negative 0.05, 0.60, 0.1. And look at that, we get the exact same number. You can do whichever one you want. I don't care. Pick which one, every one you like. Okay. Any questions on that? The question number 36 on the practice exam, I'm not gonna ask you to find like a lower or upper bound, like I'm not gonna ask you to find A or B. Just because we didn't really do that in class, like that specific problem, so I'm not gonna make you do that one on the exam. So number 36 on the practice review, you can just ignore that. Do we have to draw the distribution to get points? No, you don't have to, but like if it helps you visualize it, because I tell students to do that to visualize, but no, you don't have. Unless I specifically say in the direction, draw the distribution, right? So you do not have to. Okay. And then we'll just do number, I guess, 33, just to do one more, but now it's a word problem. So SAT test scores are normally distributed with a mean of 500 and a standard deviation of 100. I didn't know the scores were that low again. They used to be, I think when I took them, they were up to 2,400. And then I think they went back down to 1,600 and who knows what they're at now. I have no idea. Find the probability that a randomly chosen test taker scored below a 450. Okay. So once again, just draw a distribution. And the center is always the mean. So the mean, 500. And the standard deviation is 100. And they say, what is the probability you're below a 450? So 450, and I want everything below it. Okay. So what happens when you deal with a less than or greater than? Well, you're going to have to write it in terms of infinity. So step 2 is to compute. So normal CDF. So you're going to do -1 e to the 99, comma 450, comma 500, comma 100, because this right here represents negative infinity. So let's type that into our calculator. Second distribution, normal CDF. And we're going to do -1 second e to the 99. And you're going to do it all the way up to 450. The mean is 500. Standard deviation is 100. We're going to paste that in there, and I get 30.85. Eight, 4. No, I just say 5. Okay. And so that's our answer. So the probability that you're going, so the probability that a randomly student is picked that scored below a 450 is 0.305, 3085, 3805. No, 3085, sorry. I am tired. Wouldn't it be 0 for a value since the lowest score you can receive on the test is 0? I'm not sure what you mean by that question. So are you saying like, oh, I see what you're saying. No, because, well, that's actually a good point. Let's see if it makes a difference, actually. I don't think it would. No, it probably will. But let's find out. Second distribution. So let's just do 0. It might not make a difference because once you get past that point, but let's find out. No, doesn't make a difference. But yeah, you could stop at 0. Well, okay, so think about it this way. What is the probability of you getting below a 0? 0, so you're just adding a bunch of zeros. So it doesn't make a difference at that point. Any other questions?
Yeah, if, for example, if it was like positive infinity and 450 was like the bottom range, would it just be +1 E99?
Yeah, the positive 1 E99. Yep.
Thank you.
Or you could just put a really big number, whichever easier for you. But if you put like 1,000, sometimes you have to go a little bit bigger because it just depends on standard deviation and all that.
Okay, thank you.
Yep. Any other questions on 9.5? All right, so this is actually the end of section chapter 9 specifically. And now what I'm going to do is I'm going to stop this video and create another video for the probability sections like P1, P2, P3 specifically. And then I'm going to create a third video for chapter 8. So stop this video.